Let's start our new topic, which was a question practice basically on the quantization of charge. So our first topic says that the question basically, how many positives and negative charge on their cup of water? Interesting question. Okay, it says that, for example, I have a cup of water. Okay, this is my cup of water. Say anything the liter. Okay, so in the cup of water, how many I have the charges on there. Okay, so let's understand how we crack this. We know that in the cup of water is made of basically water simply, which is a formula of H2O using the chemistry molecular formula. And suppose, for example, I choose the ml is 540 ml because it was easy to calculate. Okay, now we know the mole concept. Okay, the mole concept, the number of mole is basically the weight upon molecular weight. Okay, so weight upon molecular weight. So the molecular weight is, if we say that the molecular weight we can say like 2 for hydrogen and 16 from oxygen, because 8 to the 16, so the total become 18 gram. Now because we want to calculate of mole, okay, so this ml is interesting, because if I choose 1 liter, then I have some problems because of 1 divided by 18. I choose the 250 ml and the with which was a not multiple of the 18, then there is a fractional part, so that's why I choose the number which should divide the 18. Now our whole concept, now the scenario by seeing the question is changed. We want to calculate first mole, that is the how many molecules on the cup of the water with the 540 ml. If we calculate the molecules, now if times for the charges, and then we can solve it. So the number of mole, we can 540 divided by 18, that become 3 molecules. Okay, the second point is interesting, that is we know that we have 3 molecules. Okay, so basically in a 1 mole we have 6.02 into 10 to the power 23 Avogadro number. So in 3 we have 3 into 6.02 into 10 to the power 23 Avogadro number. By using this we can calculate the number of molecules and then finally. Okay, so let's start our basic concept. Okay, so the number of mole we calculate, first write on of the water, of the cup of water. Okay, so let's suppose the volume we can say, and say the 250 and 540 ml of water. The number of mole become weight upon molecular weight, we can say the 3 moles I calculate. Okay, and the molecule on it, which one is 3 into 6.02 into 10 to the power of 23. If we calculate, this become 18.06 10 to the power 23. Okay, okay, if you want to round figure, but it is okay. So the number of molecule, it become 18.06 into 10 to the power of 23. Okay, so now we have the number of molecule on the 3 mole of water. Okay, so number of molecule on 3 mole of water, which one is 18.06 into 10 to the power 23. Let's move on to the third concept. We can say that we have H2O, which was the 1 molecule. Okay, So in one molecule, how many charge it is? So the hydrogen is 2, okay. Then oxygen is, this is made of hydrogen and oxygen. So hydrogen has 2 molecules, the atoms, and oxygen has 6 atomic weight number, 8 atomic number. So the basically we know that atomic number is number of proton, and number of proton is equal to the number of electron. So here we have 10 atomic number, which one is make 10 proton and 10 of electron. So we know in a one molecule we have 10 proton and 10 electron. So we have this molecule, since in one molecule we have 10 proton, basically positive charge, and 10 of electron, and therefore we can say that the number of charge on charge on the 3 moles, basically the whole cup of water, it is 10 into 18.06 10 to the power 23, and overall become 18.06 into 10 to the power 23 of positive charge. And similarly the negative charge is 18.06 10 to the power 24. I hope you understand the basic concept of what I am saying, that basically first we calculate then how many moles on it, then by the molecule and by the help of the concept of atomic numbers and the positive and negative charge, we calculate the whole positive and negative charge on the whole molecule. Okay, I hope you understand the concept which I want to explain you. In next class we move to the Coulomb's law. Okay, bye.